Okay, so last time we started factoring our notes on factoring polynomials and finding zeros, and we just reviewed factoring, which you actually learned last year, because you really have to know that in order to continue with finding zeros. So, we've done 2 examples, I believe. Yep, 1 and 2 examples on factoring. So now we're going to do another one, and then this time, instead of just factoring, we're going to find zeros, because the directions say factor, it's different than when the directions say zeros. Okay, oftentimes on tests, students will, even if it says find the zeros, you'll just factor and think that's the same, but they're not the same. So hopefully we'll clarify that today. Okay, so for example 3, we're going to find the zeros, and we're going to graph them. Okay, now zeros has some other synonyms that you will see a lot. Okay, Adam, if your notes, can you write down with us, please, for example 3? Zeros are also called roots. Let's see, who had me last year besides Eric? Okay, I guess it's you, Eric. Do you remember? Last year we focused a lot on this. Zeros and roots are the same, and there's 2 other words or phrases we use too that represent the same. Zeros, roots, you don't remember? They're called also x-intercepts, remember that? And solutions. And these are used interchangeably. Okay, so if the directions say find the roots, it's the same as saying find the zeros. If the directions say find the x-intercepts, it's the same as finding the roots or zeros, etc. Okay, so we're going to find, let's see, find the zeros from x cubed minus 36x. X cubed minus 36x. X cubed minus 36x. Okay, in order to find the zeros, you do have to find the factors, and we've been practicing, we just practiced on boards, finding factors. Okay, so how would we find the greatest common factor and factor it out? What would the greatest common factor be? Tyler? Okay, let's look. Do they both have x's? Shout it out. Yes, does this one only have 1 or does it have more? It only has 1, so at most we can only take out 1. Now, what's the coefficient in front of this x cubed? 1, and 36 is the coefficient of our other term. Okay, so the greatest common factor for the coefficient we can pull out is a 1. So basically we only pull out an x. Now, when you pull out a factor, you're not done. You have to divide each term by that factor. So we're pulling out an x, means we have to divide each of these terms by x. Okay, so Nathan, if we divide x cubed by x, we remove 1x. What's left? Good, x squared. And Joseph, what about the next one? If we divide by x, meaning we're removing one of the x's, what do we have?
Negative 36.
Good. Okay. Now, if you ever have still even a binomial or a trinomial that's not linear, linear is x to the first power. If you have anything larger, like x squared, you're not done factoring. Okay, if you still have x squared, we need to factor x squared. So this is the same as a trinomial because I claim that there's actually a middle term. X to the second power and 36 is x to the 0 power. I claim that there's actually an x to the first power. Do you see it? How many x's to the first power right here in this binomial? Not 2. Nope. Do you see an x to the first power right here? No. So what number represents nothing or not present? 0. So 0x. Okay, so this binomial, it's actually a perfect square trinomial, and if you don't know this right off, it's a perfect square trinomial. You can still use the box method and figure it out because we have to add to 0. We find 2 numbers that multiply to 36 and add to 0. Okay, So think about it. What are two numbers that multiply to negative 36 but add to 0? Raise your hand when you know. Two numbers that multiply to negative 36, add to 0. Thanks for raising hands. Raise your hand when you know. How would we add to 0? Think about that. How would we add to 0? Eric? And? Negative 6 and negative 6 add to 0? One has to be positive, one has to be negative, right? To add to 0? Negative 6 and positive 6. So, our factors for this problem. We pulled out an x at the beginning. And then the binomial breaks down into two more factors. X plus 6 and x minus 6. Those are the factors. And we've been doing that for a few days now, so that should be review. And you learned that last year as well. Okay, are there any questions how we got like x plus 6 and x minus 6? The directions say find the factors, now you're done. But our directions say find the zeros. So finding zeros requires us to go one step further. When you find zeros, you're actually finding where does this graph cross the x-axis. And what's the height of the x-axis? I'm going to draw this, but we're going to erase it in a sec, so don't draw this. What's the height of the x-axis? This is the y-axis right here. And you're on the x-axis. How high off the ground are you? You're at 0, right? So you're looking for, when does this polynomial equal 0? Which means you take each piece, since we're timesing, we can divide the other two pieces away, and 0 divided by anything would be 0. So we can just take each individual piece and set it equal to 0 because we can isolate it. So take each factor and set it equal to 0. Take each factor, set it equal to 0, and solve for x. So there's going to be 3 different answers for x. Take each factor, set it equal to 0, and try it on your paper, solve for x. Okay, so you have 3 equations there you need to solve for x. Okay, can you write the factors down there? Take that x equals 0, set it equal to 0. X plus 6. Well, if you need to go sit up closer, there's a seat over there next to Emily. Okay.
So we just there's 3. We just find out the answer.
Yep. Solve for x. Remember, this goes back to pre-algebra. It's inverse operation. Solve for x. What's the inverse operation? Inverse operations. Okay, I don't see very many people. Oh, you did it. Good job. Thanks for trying and working it out. Inverse operations. Amy, help me out with... This one's done, right? X is already 0. But Amy, how do we do this one? The inverse operation of adding 6 is to subtract 6 on both sides. We get x equals negative 6. If you haven't done the third one, go do the third one. Solving for x. Good. And box up all 3 of those, please. You get them? Okay. Okay, Benito, what do we do with inverse operations on our third factor to solve for x? To both sides. So the answer here would be, Benito, x equals 6. Okay, what I've just boxed up, these 3 are called the zeros. So factors was the step above, where they were still in parentheses. Once we set it equal to 0 and solve for x, we get what are called the zeros. These are also roots. These are also x-intercepts, and these are also solutions to the equation, if we set it equal to 0 and make it an equation. So we're going to now graph these. Now please draw the graph with an x-intercept, or x-axis, and a y-axis. Okay, these 3 values we just came up with, 0, negative 6, and 6, are where the graph crossed the x-axis because they're called x-intercepts. Right? So we have one intercept right here at 0. So plot the point, please. 0. We have one at -6, so 1, 2, 3, 4, 5, -6. We have another one at +6. 1, 2, 3, 4, 5, +6. Any questions how I'm getting these points? Okay, now we just have to decide what does our graph look like. So take a look at the factors. How many x's are there? There are how many? 3. So this means it's an x to the cubed, which means it's a cubic graph. You guys remember what cubic graphs look like? We have even powers or quadratic graphs as an example of an even power. Like x squared would be a u pointing up, right? Negative x squared, how does negative x squared change? Flips and points down. Good, okay? Now if we have a cubic or an odd power, like x to the 3rd power, do you remember what that looks like? Kind of like an S. It starts on the bottom left and goes up to the top right. So if you don't know these graphs, you should draw this out. And what happens if it's negative x cubed? It flips. So it starts up and goes down. Okay? So we have to look at our powers here, at our x's. We have a positive x times a positive x times a positive x on the factors. So what's a positive times a positive times a positive? So we have a positive x cubed, which means our graph will look like this one right here, the positive x cubed. So we need to start down. We're going to go up through the -6, and then we curve. We have a little bump to 0, and then we go through 0 and curve and hit +6. So it has the basic shape of the S, but because we have 3 intercepts, there's going to be some bumps in the middle. Okay, so this is a rough sketch of the graph that is focusing on, number 1, the shape of the graph, and number 2, the intercepts. Okay, you have that drawn? Great. Okay. Great, let's try another one which we've actually already factored. Example 4, we've already done the work on this one to factor it. 9x cubed plus 6x squared minus 3x. Now we're going to find the zeros and graph it. So look up above. We've actually done this example, I believe, on your notes. Find it was example 1 or example 2, and show me with your fingers in the air, example 1 or example 2, because we've already done the work. Example 1, thanks for showing me, or example 2. Good. So what's example 2? So one of you guys who found it, who would like to tell me what the factors were? Factors. Who has the factors? Arbor? Uh-huh, 3x is one of the factors, and then 3x minus 1 times x plus 1. Okay, those are the factors. Now we need to find zeros. So we have to, zeros requires us to go, hey, I don't know what you're looking at, but we're over here. Okay? Zeros requires us to go one more step by setting all of these equal to 0. Okay, so we take each of our factors. 3x, set it equal to 0. The next factor is 3x minus 1, set it equal to 0. The next factor is x plus 1, set it equal to 0. Okay, and solve all of those. So you're going to have 3 different values for x. Okay, I'd like you to try to solve them on your paper. Solve each of our factors for x after we've set them equal to 0. Show your work, like I did on the last problem. Just one sec. On the last problem I showed, I was minusing 6 on both sides. I showed my work. Or adding 6 on both sides. Okay, I show the work, please. three factors, once you have all three factors solved for, please turn to your neighbor and share what you got. Once you have all three factors solved for, please turn to your neighbor and gently if you can turn both ways. Thanks for sharing with your neighbor. And show them how you got that. Okay, Haley and Gucci, sorry to scare you. Haley and Gucci, do either one of you have the factors?
I'm doing that.
Ariana, when you're done, can you share with Cassie too? You go by Cassie? Cassie?
Yeah.
With the Cassidy? You go by Cassie? Just making sure I'm saying it right. Good. Make sure it says X equals. Make sure they say X equals, please. Hey, about 5 more seconds. Okay. Adolfo, on this first one. Thank you. 3x equals 0. How do I solve for x? This is for Adolfo. Thank you. What? By what number? Divide both sides by 3. Good. So 3 divided by 3 cancels out to 1. We get x equals 0. Because 0 divided by 3 is 0. Right? Okay. Fernando, how about this one? How do I solve for x? It says subtract 1, so we have to do the inverse. What's the add 1 to both sides? Good. So we're left with 3x equals 1. So unfortunately, we're not done yet. Okay, so we have to keep going. Emmanuel, what's the next step? To get x by itself. Divide both sides by 3. And now we get x equals 1/3, which is fine. You can have a fraction. If you got x equals 3, I think you're trying to divide backwards. Okay, and the last one right here, Noah, how do I solve for x? Yeah, subtract 1, because the inverse of adding 1 is subtracting 1. Okay, those cancel, and we get x equals -1. So these that we've... Do you have a question?
No, I got 1 because I divided the 3 first.
Okay, so you can't do that because if you divide... This is called a two-step equation, because we have two operations. We have multiplication and subtraction. So if you are dividing first, it makes it a little messy, because I'll show you what really happens. If you divide by 3, you have to divide each piece by 3. So I think you probably forgot to divide that one. So you have x minus 1/3 equals 0. Okay, and then add the 1/3 over and we get the same answer. So that's good clarification. So do the addition and subtraction first, and then you probably will avoid that problem. So these that we've boxed up are the zeros. They're also called roots. They're also called x-intercepts. They're also called solutions. Get used to all of those phrases. Now we're going to graph them. So, you need an x-axis and a y-axis. If I look at my numbers, nothing is larger than a positive or -1, so I'm just going to come out to -1 here and +1 here. Okay, everyone go put the 3 points on the x-intercept. The x-axis has 3 x-intercepts. Okay, Adam, on your graph, plot all 3 of those, please. Yeah?
How would you plot the 1/3?
Good question. Okay, first let's do 0. We can plot 0, right? It's right here at the origin. And we can plot -1. But 1/3 is between 0 and 1, right? Okay, so please tell me when to stop when I get to 1/3. No, that's not 1/3 yet, nope. Tell me when to stop when I get to 1/3. There you go. So it's 1/3 of the distance. So if you divide 0 to 1 into 3 sections, it'd be the first section. So this is 1/3. So once again, let's look at how many x's we have and if we have positive or negative. So looking at my factors, x, x, x. How many x's were there? 3. And let's see if they're positive or negative. 3x is positive, 3x is positive, x is positive. So what's a positive times a positive times a positive? Positive. So it has the same shape as our last one. We start down here, come up through -1, curve over to 0. We have a little bump to 1/3 and back up. So still has that S shape, just with some bumps in the middle. Okay, the very last thing we need to talk about is if we get repeated roots. Okay, I think that was 4. Yep. Example 5, we're not going to solve anything, we're just going to talk about it and write it down. So, if you get your factors look like this, x plus 2, x plus 2, and x minus 3. I forgot to do one thing on the graph, so write that down, and then I'm going to step back to the graph really quick. Give you 2 vocabulary phrases. I'll take your question in just a minute. We have 3 minutes left, so I'll take your question after I'm done. Okay, just so you know, on the graph that we just did, guys, it's not the time to be chatting. This highest point on the bump is called a relative maximum. Relative maximum. There's absolute maximums and relative maximums. You should have written that in. You're going to have it on the homework, so make sure you know what a relative maximum is. It's not the absolute maximum because, see this arrow on the right? It goes up, 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 up forever. So there are actually higher points on the graph. A quadratic would be an example that would have an absolute maximum. If it's upside down, then there's an absolute highest point. Right here is called the relative minimum. Because there are lower points because this graph goes down, 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 down forever. An upward-facing quadratic, Adam, I don't see you writing. An upward-facing quadratic would have an absolute maximum because it will have an exact lowest point. But these are relatives because they do go to infinity. Negative infinity and positive infinity. Okay, back to the example 5. Right here we have a repeated root. So if it's a repeated root, we say that, and you solve, and get that the root is x equals -2. We say that -2 is a multiple 0. -2 is a multiple 0. Or you say -2 has a multiplicity of 2, where 2 is the number of times repeated.